Okay. Welcome guys to the second final review session. Today we will be covering SQL and debugging. So Cameron and I will take one of each. So let me start sharing my screen and we'll get started with SQL. Oh, Cameron, can you enable me access?
Yeah, it should be good. Sorry.
Okay, no, you're all good. Okay. So I'm gonna walk through a couple of exam questions here. If at any point you guys have any questions, you can unmute yourselves and just speak out. Okay. Okay. So SQL stands for Structured Query Language. Before we start, I wanted to jump into a little bit of context. So SQL is a declarative programming language. So what exactly does that mean? So previously in Python, you'll notice that when you write code, you actually describe the exact set of computations to kind of calculate or retrieve the desired output through different control logics, such as if statements, for and while loops, and data structures, such as lists. An example of this would be, like in real life, would be a Lego toy set instruction manual tells you the exact procedure to put each piece together. So basically in Python, you kind of have to tell the computer what you want and how you retrieve it. In contrast with SQL, it's a declarative programming language. So what this means is for SQL, you kind of describe what output you want without specifying how to kind of calculate it. So another real life example for this would be a little girl tells her parents she wants a Lego set, but she doesn't really tell her parents how to get one. So you can kind of see the differences between the two. One tells you what you want to get and how you get it, and the second one just tells you what you want. So just as a recap, this is what a basic query looks like in SQL. So you have your select statement. You select specific column names from a table. And again, you can have multiple tables. You just join them using the comma. Let me see if I can use a pointer. Yeah. And then if you only want to select a certain subset of columns, you use the where and insert a condition. And if you want to order columns, you use the order by. Okay, so these are basically, I would say, the 4 basic keywords you use in a query. Here they are in a more expanded format. Some other ones you want to be aware of are the order by, and the limit. So basically, again, the order by, if you do not provide like how you want to order them by, the default is ascending. So if you want to do something in descending order, you have to provide the DESC keyword. Okay. The next one is limit, and basically you can limit the amount of output you see. So let's say, for example, I want to select all the columns of a specific table, but I want to limit them to the top 5. So what SQL does is SQL collects all the columns, and then once it sees that limit keywords, it starts from the top and counts down all the way to the number you provided here. Okay. So a good use of limit would be like, let's say you have a table called movies, and they have ratings, and you want to pick the top three rated movies of the year. So what you would do is you would like select movies from your table, order by ascending by ratings, and limit to 3. Okay. And the next one that I want to talk about is distinct. So basically, this is just used to extract unique values. Okay. And then for alias, if you want to call your new table something else, you just use the as keyword. I'm sure you guys are very familiar with the as keyword in the labs and homework that we've done. And then if you have more than one condition, similar to in Python, you can use the and or command. Do we have a question? Let me check the chat. How about group by? Yes, good question, Rajit. So we can also use group by. Haven't listed it here. I think in the next slide I have listed it out. Yeah, you can go through these in your own time. Oh, I guess here I've expanded it a little bit more. I guess I didn't list group by here, but yes, if you want to kind of segment your columns by specific condition, you can use the group by. And I'll dive deeper into that in the aggregation portion of the slides, okay? So cool. I've written a couple of extra notes here. You guys can go through this in your own time. I think the main thing to understand is when you do an order by, it's always in ascending order by default. So if you want descending, you have to write out the word DSC. If you write out ascending, there is no con to that your code will just do the same as the default. But just to be safe, I would always recommend either writing descending or ascending in case you forget. Okay, cool. So just as a warm up, I have a table here called ratings, and I want you guys to write a query to select the titles of all movies that have a rating greater than 7 in alphabetical order. Okay, so you want to notice that, that the table, the rating column is in strings. So there's an easy way to order by alphabetically. So why don't you guys take like 1 minute to 1 to 2 minutes to kind of figure it out on your own, and then we'll go through the solution together. Oh, and just a note, we have provided the correct output that your query should return on the right-hand side. Okay, let's walk through this together. So first thing it says is in the question is that you want to only select the titles. So this should tell you that you want to select only the title column. From, we're only given one table, so this is easy. We just put from ratings. And we have a condition. We only want to select the tables whose ratings are greater than 7. So we need to add a where clause that says where the rating is greater than 7. Okay, and rating is another column in ratings. Okay, and because we want it in alphabetical order, we want to use the order by, and we want to order by title because we are selecting the title here. Okay, again, I did not have to provide ascending because default is ascending for order by, but you can. There's no harm in it. Okay, and just to recap how you create a table in SQL. So how it works is you use the create keyword to define the table name. So the table here is called ratings. And for each one, we use for each select statement, for the first row, we use the as to define the column name. So we select the matrix as the first input to the column title, and 9 as the corresponding next column for rating. Okay? Any questions on this one? Nope. Okay. Awesome. Cool. So moving on to joins. So we can grab multiple items from different tables at one specific time. So to do this, usually we will give a table a name using the alias keyword as. And when we select from the tables, we use the same OOP-esque syntax in which we use the dot notation, with the thing before the dot as the table alias or the table name, depending on if we aliased or not, and the right-hand side as the column that we're accessing. Okay, and when we join, we don't explicitly call or like use the word joins, but when SQL sees us pulling from multiple tables in the from clause, it will perform a join under the hood. So again, just to reiterate, there is no explicit join statement, and rather we consider 2+ tables to be joined when they happen together in a from clause. A table join causes every row in one table to be associated with every row in the other table. So for an example would be a table of length m joined with a table of length n will result in a table of length m times n. Okay, and to see it visually, let's say we have these two tables, C and D, and we're joining them together. So you can see here on the right-hand side, this is the combination. So we're basically cross-multiplying every row against each other. So C has 2 rows here, D has 2 rows here, 2 to the power 2 is 4, and so that's why we see 4 rows in the output. Okay. So now to test our knowledge of joins, I want you guys to write a query that selects the title and difference between this table called developers, start year, and the game release date in reverse alphabetical order. And the other table that we want to contrast is called Vidya Games and has the columns title, developer, release, and genre. So just to visualize, this is what the other table looks like. So it has the name of the game, the release date, the developer, as well as the genre, okay? And the table developers only has the developer and the year. So since this one's a little bit complicated, maybe let's take 2 minutes. One thing you want to note here is that here we also want to order, but now we want to order in reverse alphabetical order. Oh, looks like we have a question. Can you quickly go back to the other table? Yes, I can. Yeah, no worries. So I'll move back to the question itself. And I've listed the different columns in the other tables. So in case you want to quickly reference it. Okay, let's quickly go through this together. So the question asks us to select the title and difference. So again, in the select statement, we want to narrow the columns we want to extract. First is title, that's a super easy one. And the next one is the difference. So because difference isn't given to us as as an exact column in one of the tables, we actually have to manually compute it, okay? So what this means is first in the from clause, we know we want to do a join on video games and developers. So here I've just aliased them. You want to alias here because both of them share the column year. So if you don't alias, what you have in the difference is year minus year. And so SQL will actually error because SQL doesn't know which year to kind of extract from. So make sure that if you have the same columns, always alias. Again, even if they have unique columns, there's never a harm to kind of alias between the two tables. I often alias because I find it nicer to work with smaller table names. Okay. So here, because we want to find the difference between the developer start year and the game's release date, because you'll notice that the game's release date is actually a bigger number than the developer start year, you kind of want to put that first in the when you subtract. And we will alias this column as the column name difference. Okay. And because we don't want to calculate every difference between the developer start year, every developer start year, and every game's release date, we need to use a where clause to kind of specify which rows we want to match up against each other. In our case, we want to look at the similarities between the columns that would be shared in the developers column. So to make sure that we're subtracting the right rows, we say we only want to select the rows where the game's developer is equal to the developer's developer that we're extracting from. Okay. And because in the last component it says we want to order it in reverse alphabetical order, you'll notice that title is the only one that is actually in a string format. B.year minus D.year will actually become an integer. Because it's specifying alphabetical order, integers cannot be, it doesn't make sense to order integers by alphabetical order. We only talk about that in strings. So this should give a hint that we want to order by title. And because we want it in reverse, we have to add the keyword descending. Okay. Does anyone have any questions there? Nope. Okay, sweet. Let's move on. So moving on to another question. We have two tables here. One's called Straight Outta Compton. The other one is called Albums. So for this query, I want you guys to write one that will output the real name of each member and his album in alphabetical order by name. Okay, so once you guys take 2 to 3 minutes to kind of work through this on your own. Content query. Thank you, Rajit. Oh, and for the name, I guess if this isn't clear, we should be using the stage name to order the resulting table by. Okay, cool. Let's step through this together. So before, for this one, before I directly show you the answer, I kind of want to share with you kind of how I would approach this. And hopefully this will match some of the logic flows that you guys went through when answering. Okay, so first things first is looking at this question and look at these two tables. Because we want to output the real name of each member and his album, straight out of Compton, this first table doesn't provide our album name. And so this should tell me or tell you guys intuitively that we should probably be using a join, okay? So in our from clause, I'm going to use two of these things, okay? I'm gonna join both of these two tables together. And it looks like I want to output the real name. Okay, so from here, this is easy enough for the straight out of Compton table. We only want to extract the real name, okay? And we want to extract the album name as well. So from albums, extract the album column, okay? Now, the hardest part, I would say, about joins is kind of specifying which rows we want to look at, AKA, what do I put inside the where condition, okay? If we wanted to select all rows and all possible combinations, we wouldn't provide a where, but clearly it's a question. We want to output the corresponding album to each member in the first table, okay? So how we do that is, let's look at each of these two tables, okay? And so so there's one column that actually specifies which of these rows should be tied to the same real name singer, okay? And can anyone tell me, maybe if you guys unmute yourselves, what you put in for the where clause? Let's see in the chat, stage name equals artist. Yes, Jeannie, that's exactly right. So if you look at the second columns in both of these tables, you'll notice that some of them share the same item. So for example, Ice Cube here matches the artist Ice Cube here. So we can successfully say that this stage singer has the album I Am the West. Okay, so in our whereby clause, we will order them by where the stage name is equivalent to the artist name. Okay, so looking at the answer, it's exactly as I said. So first, we use the from clause to join these two tables together. I've aliased them to be the name M and A. First things first, you select the real name and the album. Again here, once you've aliased, it's always good to use that dot notation here. Even if you use this dot, even if you don't alias, you can just say real name and album, just because each of these columns are unique titles, okay? The where clause is the same as Jeannie said. One thing I like to note though is that instead of an equals equals sign like we did in Python, in SQL, equals equals is equivalent to just a single equals, okay? So that's just something to look out for. And because we want to order it in alphabetical order by name, we just order it by the stage name, okay? And again, you can add an ascending keyword here. Both answers would be correct. Okay, any questions on this one? Nope, okay, cool. So now we're gonna move on to aggregation. So basically we use aggregation to combine or kind of like smush the contents of a table or group using the keyword group by, okay? And there are four main aggregator functions that will come in handy for this class. And how you apply them is you apply them like functions. So let's say I want to use max. So what happens is in your select statement, you kind of encapsulate it like you're calling a function, okay, for each of these four things. And then again, if you're using aggregation, usually you will have a group by statement, okay? And you can plug in any column or any condition that you want to group by, okay? So the four main ones, I'm gonna run through them really quickly. So the first one is max. Again, it just returns the max element of a table or group. Min does the reverse. It will reverse the smallest or minimum element. The third one is count. So count is a little bit tricky to conceptually understand. So what count does is once you've grouped your your columns into different groups depending on what condition you put inside here. Count basically counts the number of rows that fall into a specific group. Okay. And then for sum, it just returns the summation of all the values in one group. Okay. And so we'll see this later on, but you can always refer back to this or write it on your cheat sheet for just to note when taking the exam. Okay. In addition, you can use the having clause like where to filter out entire groups. So if you have a group by aggregation and you want to filter them out even more, you can use the having clause. And to go more in depth into that, you can go back to our SQL lab slides where we talked more about that. Okay. Okay, so given this table, I want you guys to write a query that selects the title and release the oldest game for each developer in reverse chronological order. And again, this table was called, I believe, Vidya Games. Let me just write down the name in the chat so you guys can refer back to it. But feel free to take 1 to 2 minutes to work through this on your own. I think I'm missing an up here, so this should actually be write the query that selects the title and release date of the oldest game for each developer. So sorry if that was kind of confusing. Okay, let's go through this together. So looking at the question itself, it may not stand out, I guess, in the beginning to see why we need aggregation, okay? But if you look at the wording really carefully, you'll notice that if you see here, and release of the oldest game, okay? So whenever you see something that's like summation, earliest, maximum, minimum, that should kind of flash a light bulb in your mind that, maybe we should be using aggregation. Because aggregation can easily, like you saw before, the 4 main aggregator functions, can kind of really easily give us like either the maximum or minimum, just calling them like a function in the select statement, okay? So for here, because it says, okay, so starting off with our select, it says we want to select the title, so that's super easy. You just pass in the title column, and release of the oldest game for each developer. So we know we want to specify the release date. We just don't know kind of how we want to format it by. Because it says the oldest game and dates, again, the older dates are smaller than the earlier dates. So that's why we use minimum here to kind of get the earliest or oldest game. We only have one table that we're extracting from, so we just pass it in, Vidya Games. And because we don't want the minimum release date of all the different game titles, we only want it for each developer. So this should tell us that we need to use a group by. So we want to group by developer because what this does is, looking back at this table, right? How SQL groups it is the first 2 rows would be grouped together because they share the same Nintendo. Tetris would be grouped by itself because it has a unique developer. And Assassin's Creed, Watch Dogs, Prince of Persia would all be grouped together because all come from Ubisoft. And Civilization, again, would be its own one thing column, okay? Because no other game has Microprose as the developer in this table, okay? So in this table, once we group by developers, we should see 4 unique groups, okay? Just like how I broke it down. And within each of those 4 unique groups, now we want to select the game that had the earliest release date. Okay, so taking, let's say, the Nintendo group as the first example, we would extract Super Mario Bros. Because 1985 came before 1986. Okay, for the one item groups, such as for Tetris, there's only one title, and so we would just extract that title itself. Okay, so for the group with Ubisoft, just to reiterate once again, we would be extracting Prince of Persia because in there, the minimum release date is 1989, okay? So whenever you use aggregation, typically you will also have to use a group by, okay? And once you've grouped all your titles together, then whichever aggregator function you've used, in our case, it's minimum, you will apply that aggregator function on each of the groups, okay? That could be kind of confusing. So let me summarize. So once you group them together, let's say, let's take the first 2 rows as one group. Then whichever of the 4 aggregator functions you've used, either max, min, count, or sum, you're going to apply it onto each group individually. Okay. Any questions there? No? Okay. Cool. Hopefully that cleared everything up. And again, the last thing is because it's specified reverse chronological order, you see here in these 2 columns, one is in the string format because it's the title. One of them is in integer format because it's dates. So here, chronological order, typically when we talk about string columns, we will say, if we want to order them, we'll say alphabetically. And for dates, we'll say, or integers, we'll say chronological. So this should give a good indication that we should order by release. Because it's reversed, we want to add descending, okay? And if you don't know if one column is a string or which one is an integer, that's perfectly okay too. You can also kind of infer because here we have names of things, and the second column we have dates. So whenever we say in real life order by chronological, that should kind of intuitively tell you that we want to order by the times and not by the names, okay? Because it doesn't make sense to kind of chronologically order Legend of Zelda versus Super Mario Bros. Okay, it makes more sense to do it alphabetically if we wanted to order by title. Right? Any questions on here? Okay, awesome. Okay, so I think that is enough of review and going over the 2 harder topics, aggregation and joins. Now we're just gonna go over past exam questions, okay? So this one comes from spring 2019. If it's a little bit hard to see the question itself, you guys can pull it up. I believe all the exams are on Piazza in like a bank format, so you guys can click on there, okay? So here we have the following SQL questions given 2 different tables. So we have a table called players, and we have a table called stats. So for this review session, I'm going to go over spring 2019 SQL questions as well as fall 2019's. Just as a quick poll, would you guys prefer to work on it together and then go over it together as a group, or would you like to kind of walk through it together? Maybe in the chat, you guys can specify or unmute yourself so we can take a poll there. Click on it, then go over as, okay. Okay, cool. So it looks like most of you want to work on your own. So maybe let's take 3 minutes to work on part A of this question. Oh, shoot. I think this gave, okay, never mind. Sorry, I thought this was the answer to this query, but this question is asking for the output. Again, if you guys have any questions while working through this, feel free to write in the chat or unmute yourself. Okay, let's walk through this together. So looking at this query, first things first is I see that there are 3 different things listed in the select statement. That should immediately tell you guys that our resulting output will only have 3 columns, right? Because the select statement selects which columns from a specific table should be extracted, okay? And here we're only looking at the stats table. So this is the second one here. And it looks like we have a where and an order by. Okay. So first things first, we only want to select specifically from the stats name column where the point is greater than the minutes. So I guess how I would approach this is I would slash out the rows that don't satisfy this where condition, because if they don't satisfy, I don't want the name or the summation of the rebounds and assists plus the points, okay? What this means is looking at stats, for the DeMarcus Cousins, I would slash the row out, just because, maybe just in pencil, because in the following questions, you might need it. Because we don't, the minutes does not exceed the minutes is not less than the points. sorry. But for the rest, I believe they all satisfy, yes, because for the rest, the points column is always greater than the minutes. Yeah, okay, cool. So this should tell us that we should have 1, 2, 3, 4. We should have 4 rows and 3 columns in our resulting output, okay? From here, we want to select the name, rebounds plus assists. So for the second column, you might have to do a little bit of extra computation because we want to sum up these last 2 columns. So what I would do is on the side, maybe write, in the first one, 8, 10, 20, and then 70. And now once we've calculated what the second new column would be, it looks like we have an order by. Okay, so looking at this order by clause, we have 2 columns that we're trying to order by. So that might seem kind of confusing, but how this works is the first column that you specify in the order by, in our case it'd be points, that's how you order your columns by, okay? If there is a tie in the number of points, then you'll break the tie by ordering by name, okay? And because name is a string, we order it in ascending alphabetical order because there is no keyword here. So the default, like I said before, is ascending, okay? So how this works is breaking it down. So points will also be ordered in ascending order because there is no keyword. So the first one who has the least amount of points, it looks like it's Leonard. So it looks like he has the least at 18, okay? And once we've calculated prior, the 10 plus 10 would be 20. Then we just insert his name. Then moving on to the next highest points, it looks like we have a tie at 35 between Kevin Durant and James Harden. To break that tie, we figure out which one comes first by name, okay? So if we were to order these alphabetically in ascending order, J comes before K in the alphabet, so we put James first, okay? Then Kevin. Then lastly, we have the highest amount of points from Oski, so we just pass him in as the last row to our column, last row to our table, sorry, okay? I think we have several questions. How exactly to order with 2 parameters? Oh, hopefully I answered that, but just to review, first you will order by the first column that you specified. If there's ever a tie in that, we saw here with the 35-35, then you will break that tie by ordering by the name column. Okay, sorry if I missed that. Ascending order by first name. Yes, so because there is no keyword here, oh, okay, sorry. We know we have to do ascending order, and if it's by first name, so it's actually based on the entire name. But what happens is, if you look at here, Kevin Durant versus James Harden, because the first 2 letters, you start ordering alphabetically by looking at each letter starting from the left. So because K and J are already different, we know that James comes before Kevin. But let's say both of them were Kevin, okay? Then when you start matching them alphabetically, starting from left, the first name is all the same. Now, looking at the last name, the first letter, D versus H, D will obviously come first in the alphabet. So Kevin Durant would come before Kevin Harden, okay? So it's by the entire name row value. Just because in our case, the first letter was automatically different, so we didn't have to look at the last name, okay? Hopefully that answered that question. Could you order points ascending and name descending, for example? Yes, I believe that is a possibility. You would just have to specify before the comma, you would have to add like the keyword descending or keyword ascending. Good question. Okay, let's move on to the second part. So now we're actually going to write a SQL query that retrieves the name of all players who had more rebounds than assists, okay? So you guys can take maybe, let's say 2 minutes on this. One thing that I like to note here is that the table stats already has all the information that we need, just as a clue, because it maintains the rebounds and assists. And so this should give indication that we don't need to join, because we don't, here in the SQL query, we only need the name. We don't care about which college the people came from or what age they are. Okay. Okay, because we're running a little bit over, I'm going to quickly go over the solution. So because we're only looking for the name, that's easy to put inside the select clause. We just pass in the column name. Like I said before, the hint that I gave, the table stats actually contains all the information that we need to write the query. So we don't need a joins. We just need to extract from the table stats. And we only have one condition. We only want the name of the players whose rebounds are greater than the assists. So that's easy enough to do with the where clause and the greater than equality sign. Okay. Any questions on this query? Nope. Just a note, because we never specified how we wanted to order by, we don't need to include that order by clause. Okay. Cool. Let's move on. So I guess for this one, yeah, why don't you guys try to do B through E together or independently, and then we'll go through them maybe for this one, maybe I'll give you like 5 minutes. And it's okay if you guys don't finish. We just have a lot of more content to review, so I want to make sure that we can get through it all in this 2-hour chunk. Again, if you have any questions on how to solve it, you guys can always type in the chat. Oh, just a note, we already solved for B in the previous problem. Sorry, for some reason my screenshot also included B. So we're just looking at working through C through E. Okay, it's been 5 minutes, so let's walk through these together. So before I show the answers for this one, I'm just gonna walk through a little bit of intuition. So for the first one, oops, it says write a SQL query that retrieves the name and their points per minute for all players who played at least 1 minute. So again here, looking at these two tables, we actually do not require the table players for this query, just because, again, we don't care about which team they're from, which college they're from, or what age. Our stats table maintains all the information that we need. Okay. So for the first column that we want to retrieve, name, that's super easy to do. We just select name. We don't need to mutate it in any shape or form. Okay. The second column that we want to extract, points per minute, is a little bit tricky. Okay. So if you see here, the points is broken down as to total points that were collected, okay? To calculate points per minute, what we need to do is we're actually given this handy column minutes. If our total amount of points that were scored in that amount of minutes, so how this works is, sorry if that was a little bit confusing. Looking at the second row, Kevin Durant's name, he scored 35 points in 28 minutes. So to kind of figure out what his points per minute rate was, you want to divide the amount of points total he scored divided by the total amount of minutes he played. So 35 divided by 28 should give you his points per minute. Okay, so that gives you a little bit of intuition as to how we can calculate that. And it looks like we only want to select the players who played at least 1 minute. So because we only want to select a certain subset, we should be using a where clause, okay? And to determine if a person has played at least 1 minute, there are several ways to do it, but I'll walk through it in the answer. For question D, this one writes a SQL query that retrieves the name, college, and points of all players. For this one, you will have to do a joint, and I'll show you that in the answers. And then for the last one, this one's a little bit tricky. This one will also be using a joins, but you will have to alias it somehow, okay? Because we will have to be joining from the same table. Before I go into the answers, I believe I had a question. Let me see. Can you also go over the standard order of the keywords? Yes, so basically, I can walk through them one by one. So looking at the first one, you always want to put your select statement first. That always comes first as a first clause. The second clause, so in the first, one of the initial slides that I had on this slide deck showed a basic query. If you want to write a very simple query, that's the format that you follow. Okay, so I would refer back to that. And we will release these slides on Piazza once they're done. If you want to add like group by, order by, those will always come at the end. Okay, so typically after the where, you'll see like limit, the limit keyword, or the group by keyword. Okay, cool. But it's always helpful to write down that basic query breakdown that I showed in the, I think it was like the second slide or something, and jot it down on like a cheat sheet or something to refer to during the exam. Okay, but the first one will always be the select statement. And so for part C, like I said before, we want to extract the name, and to calculate points per minute, it's a simple divide, points divided by minutes. We're looking only at the table stats. So we only need one table in the from clause. And to determine if players have played at least 1 minute, there are several ways to go about it. So one thing you can do is you can say where the minutes does not equal to 0. So that means the player, you can't have negative minutes. So the player has played 1 or more. Just a quick note on the syntax. To do the not equals to, you do the exclamation point, then an equal sign. Another thing you could do is you could do minutes greater than equal to 0. Greater than equal to 1. That will also give you the players who have played at least 1 minute. Okay. I think I also had another question. Let me see. Oops, sorry. Oh my gosh, my chat box is not cooperating with me. Okay, cool. So what was that question? For D, write a SQL query that retrieves the name, college, and points of all players. So the reason why we need to have a join here, I kind of alluded to it in the previous slide, but it's because like if we look at players, the table, it gives us the college and the name of the player, but it doesn't tell us the point. And similarly, stats column only gives us the name and the points, but it doesn't give us the college. So that should indicate to us that we should be using a join, using players and stats. Okay. Here we don't alias it because the tables that we're looking at aren't the same. You'll notice here that when we select the name, both of them share the same name column. So there you will have to use dot notation, just using whichever table as the name before the dot. Okay. If you just said select name here, you'd actually error because both of these tables actually share name. And so SQL doesn't know which name column that you want to retrieve from. Okay. So if you don't alias, but you share the same column name, you will have to use the table's name in the thing before the dot. Okay. And the other thing to note here in the solution, because joins do cross combinations across the rows, you need to specify the joining condition. So in our case, we don't want to combine every college with every player. We only want to select where the stats name equals the player's name. So for the DeMarcus Cousins, we're looking at their college in Kentucky. We don't want to be looking at Kevin Durant's college in Texas. Okay, so it's important in join clauses that you typically have a where clause. I believe I had a question. Oh, 2 questions. Could you still alias it as P, and S? Yes, that's a good question, Josh. So here, yes, it's never wrong to alias. In fact, I'd recommend you alias because in the real life, you'll notice that your database actually will expand or table will expand given the amount of knowledge. And so it's a lot easier when you alias, both in terms of conciseness, but also just to keep track of which table you're referring to. So yes, if you alias this as from players as P, stats as S, you would just select s.name or p.name, whichever one works, okay? Cool. So looking at the next one, get all unique pairs of players' names who scored at least 30 points in the game. I believe this is a typo. I think we said in the question itself, it said 60 points. So here, however, in part D, we had a choice whether or not we want to alias. For part E, we actually don't have a choice. because we want to get all unique named pairs of players who scored at least 30 points in the game. So what this means is we need to join stats on itself, okay? With each row of one table as one player and the second table referring to the other player, okay? So here we'll alias it as A and B. And because we're looking at unique players, one thing you can do is you can say in the where clause, you can specify A.name is less than B.name, because this guarantees us that the name that we're looking at in the first stats table does not match the name of the second table's name. And there are a couple of ways to kind of do this. You can use this notation with the not equals to. You can use greater than A.name, greater than B.name, as long as it's not using the equals operator, okay? So that's the first where clause that kind of tells you the unique pairs. The second one is we only want to extract the pairs who've scored at least 60 points. So we need to make sure that the summation of their points is greater than 60. And I think in the previous one, in the previous question, we wanted to, if you look at the ordering in the expected output, they're actually ordered alphabetically. So you want to order it by the first column's name, okay? Because if you notice here, sorry, looking at it, the first column is ordered alphabetically, but the second column is not ordered alphabetically. Because if it was ordered alphabetically, Oski Bear would be with the other Oski Bears, okay? I believe we had a question. Oh, we have a lot of questions, okay. Can we do not equal to instead of less than? Yes, Bridget. I believe I covered that, but yes, you can use any aggregator or any operator to determine if they are unique. Just make sure, again, not to use that equal sign. Greater than stops duplicates. Oh, okay. So actually, something to note, Cameron brought this up. Thank you, Cameron. If you use the less than operator, it actually will automatically prevent duplicates from happening. So I guess instead of using the not equals to, we would recommend, if you want to get unique names, using the less than operator. Okay. Would order by A.name, B.name also be correct? Order by A.name. For Jeannie, hopefully I answered it in the previous question, but in the previous slide, if you looked at the outputs, the first column is ordered by alphabetically, but just to pose a question, is the second one ordered alphabetically? And so the answer would be no, because otherwise Kevin would be before Oski. And so this tells us we can only order by the first column. Okay. Could you also do greater than also? Yes, I believe so. So I want to make a note on what I said before. So before I said not, you could use not equals to. That's fine, but what happens then is you kind of get duplicates. What I mean by this is, looking at this one, DeMarcus Cousin and Oski Bear would show up as one row, but Oski Bear and DeMarcus Cousins would show up as an additional row here, okay? Because the not equals to, what happens is it combines like everything that's not equal to in each table, if that makes sense. So your output would actually be incorrect here. If you wanted to use the not equals to, you have to add additional clauses to make sure you stop duplicates, okay? Does that make sense to everyone? Did anyone have any questions on that? No? Okay, cool. So just to reiterate, I guess then I would suggest you guys use the less than operator when trying to get the unique values from a SQL query. Because we're running a little bit over on time, I'm going to save Fall 2019's exam in the slides, and I will share them on Piazza. But now we will move on to the debugging portion.
Okay, cool. Debugging. Let me share my screen. Okay, can everyone see this? There isn't really like much to review, so it's just coding stuff. But everyone can see it, yeah? Okay, cool. Okay, so I guess the debugging is just gonna be a bunch of examples of code that's wrong, and then You guys will just fix it. And so the hardest part about debugging is, well, like debugging just sucks in general, just in coding. I'm sure you've like learned it doing Queen Ant or something, where it's like you think your code is right, but it's wrong, and so you have to like you kind of have to convince yourself why it's wrong, even though you think it's right. Um, and so it's like this weird process where you have to like throw away your ego because you were wrong. um, but it's like non-trivial. And so, yeah, but at least now you're given something that is wrong, and you just have to figure out what is wrong. So yeah, let's just start with the first question. So you, in the ADT lab, you made a city ADT, which had like a distance. You wrote like a distance function and a closest function. And a city had like a name latitude and longitude for its location. And so I kind of turned it into a class here. So it has an init, which sets the lat and lon. It has a distance that takes in a city, and then it computes the distance between the current city and this city that's inputted here. And then there's also this closest method, which takes in two cities and then returns the name of the closest city. So there's a couple of errors here. Yeah, so there's errors in the distance and, well, actually there's errors in all three methods. So you kind of want to fix this function so that it works for anything. So if I were to create a city or create two cities and compute the distance, then it would be correct. Or if I created three cities and took the closest one, then it would give me the right name. So try and see what's wrong with this one. I'll give you guys like 3 minutes here. I would start with the distance method if you're stuck. I think that one might be the easiest. We can write out some examples too. Okay, how are you guys doing? Here, it's okay if you're not done. This might be this is the first. This might be one of the first times you're seeing like a problem like this, so it's okay. So let's just look at the distance function. What do you guys think is wrong with this? I guess a hint would be in the doc test. where I create a city and then I do c1.distance c2, which is the same as saying city.distance of c1, c2. Yeah, so the first one is that lat, it would look in like it would look in the global frame for lat, but it doesn't exist. We want to use the instance, the instances lat and lon. So we would do self dot. Nice, Rebecca. Remove the slash. Oh, this slash would, oh yeah, you can take out the slash because it's within parentheses. But it just tells Python that the code continues on the next line. But yeah, we can take it out. Yeah, and then Pardis gets the next one where there should be a self in this distance here. And you can see that even if you don't, so if there's a self here, then there should be a self in the distance function. Another way to see it is that when you do c1.distance c2, it's the same as this city.distance c1, c2. And so it takes in two variables. Yeah. And Rajit said the same thing. Yes. So cool. So that's everything that's wrong with distance. Let's go on to closest. What do you guys think is wrong with this? Or is there anything wrong? Oh, I misspelled distance. City.distance. Oh yeah, right. So you would have to do city dot. So you can do city dot distance like this, or you can change it to self dot distance of city1. Yes. And then you want to do that for both D1 and D2. Okay. Should we have self in the init? Oh yes. Okay, so that's the last one. So yeah, so Yomeho says we should put self in the init. And then yeah, Rebecca points out the last thing where we have to have self.name, because in this closest method, we have city1.name. And if we don't have line 13, so if we don't have self.name in the init, then it doesn't exist. So we initialize the name. Yeah, initialize. Seems like everyone got it, so that's really good. Or a lot of people understood it. Any questions on this one? Okay, let's move on to the second question then. So this one, let me move this out of the way. So it's in nested. So you're given a value v and a nested list big L, kind of like 5 or and then this nested list, and then you return true if it's a value in this nested list. And then so like this 9, so in this second example we're trying to look for 9, and the 9 is right here deep in this nested list. And oh, and then the L can also be just a number as well. So yeah. And then let's see. So the code here says if the first value isn't a list, so you can assume that everything's just a number in here. So L is either a list of numbers and lists. So if the type of the first element isn't a list, then you just return if v equals L, and then otherwise you recursively call on v and the rest of the list. So I'm gonna try and work through this one for a couple minutes. This was on a 621A exam, and it's a pretty hard problem actually. It wasn't debugging, it was like you do the problem. So but similar. Yeah, sure, Josh. So you're given a value, and then so you're either given two numbers, and then so you'll return true if the numbers are the same. So that's the last example. Or you're given a number, and then you're given a nested list of numbers, and then you want to return true if the number v is found in that nested list, and false otherwise. Okay. It's okay if you're not done, but let's see what you guys think. What are some thoughts for this one? I guess let's look at the last example. Find 1, 1. What would happen in this code? Find 1, 1. So find 1, 1 would error. Do you guys know why it would error? Right. Yeah. So Rebecca says L is in a list. So V is 1, L is 1, and then so you're going to check if type of L at 0. But then L at 0 assumes that L is a list, but it's a number. So then you'll get L is non-iterable kind of error. So that doesn't quite work. So what do you think? What should we put in here to make it work for this last case? Like, how do we change this line? So we know that we can't subscript. So what we can do is just delete the subscript and say, okay, well, if it's a number, right? If L is just a number, then we just return if they're the same number, just like this. So that's what this last case is. So if you're given some recursive call and try and go through like a simple case to see if it works, and then you might find an easy bug there. An easy bug to find. Okay, so now what's the problem with this line? So if L is a list, right? Because if it goes past this if statement, then L is a list. So if it's a list, then we check if V is in the rest of the list and return that. What's missing? I guess, what if I had this example? Should return true. Yeah, so this function doesn't check the first element. So it's like saying this, if you use a leap of faith, this will return true if V is in the rest of the list, but what if V is the first element in the list? We never check that. So you can say in nested V L at 0 or in nested V L at 1, the rest of the list. So this will return true if V is in the first element of the list. And remember or note that you have to do a recursive call in nested, because L at 0 might be it might be a list. Yeah. And I think when they formed the question or formulated the question, they said that you can assume that L is non-empty. So yeah. Oh, but you still might get an empty list. You might have to have something like check if it's empty. But this is the general scheme of things. Any questions?
Does it check like for the in nested VL0? Would it go through every single item in the like list? Like would it, like if the 9 it was like 394, would it still check all the items like in that list?
Oh, if I did, so if this, in this example, instead of 934, you say if it's 394?
Yeah, so like because L0 is like the first item in like that list of 934, right? So like
Yeah.
what if the first number was like a 3 and not a 9? What it's
Yeah. So then this would return false, right? Because then it would call in nested of 9 and 3, and that would return false. So then you would call in nested on 9 and then the list 9-4.
Oh, okay.
And then it would eventually call in nested 9-9.
Got it. Thank you.
Yeah. Yeah, debugging is a new format. So that's why we're going over it. It'll most probably be on the final, something similar to this. So yeah. Okay, any questions on this? This is a hard problem just in general. And there's a bunch of ways you can do it. You could also, if you came up with this return function where you return any of in nested of Vx for x in L. So this also works. It calls in nested on every element in the list in a for loop, and then checks if any of them are true. So it's basically a for loop version of this. But yeah. Okay. Any questions? All right. Then let's move on to the next problem. Okay. So let's see. I didn't write doc test. I was supposed to. So you're given the, say this is the link class. You can imagine that you have like the big link class from class, but this is all you really need for this problem. So you're given the link class, and then you want to write an insert function that is mutative. So that means, yeah, so it's mutative. It changes the original linked list. and it inserts some value val at an index I. And so yeah, and then I think, okay, so the function says if the link is link.empty, then you raise an index error. Otherwise, then you check if I is equal to 0, and if it's 0, then you're going to do this mutative case where you change you store the value at that node in this variable v, and then you set the node's value to val, which is what you want to insert. And then you create a new link with the old link.first, and then so that's the new value. And then you point to link.rest, and then you set the link that you're currently at, that link.rest, equal to the new link you created. Yeah, so this one works. So I guess if you're given the link list like 3, 4, 5, and then you want to insert, or sorry, 3, 4, 6, let's say, and then you want to insert a 5 between the 4 and the 6. So what you're going to do is you're going to be at this 4 node, right? Say like your recursive call is at this 4 node here. And then what you're going to do is you're going to create this new, so you're going to create this new link, which is, so you're going to set, yeah, let's say we're inserting 5 where the 4 is, right? So you're going to insert, you're going to change this node to a 5. That's what the link.first is changing it. But then you're going to set the link.rest equal to this new link here. And that new link is the original value, which is 4. And then this 4 is pointing to link.rest, which was this 6. So yeah, I don't have a whiteboard, unfortunately. So it's kind of hard to, because I can't draw it out. But you can assume that this one works mutatively. Let's see. And then the last part is this. So then if we return link of link dot first and insert of, okay, that. Okay, so now, and then the last part here is we are returning this new link, which has link dot first as the first element because we're not inserting anything yet, and then the recursive call that inserts it later on. And then we go down by 1 here. So I accidentally had the solution here, so hopefully you guys like weren't looking at it. So this is what you would be given. And you want to try and find the error here. There's a couple of errors. Oh, Josh, I didn't see your comment here. For the last question, if it would go in the if statement, then return true. I'm not sure if you were thinking if that's a bug. I guess if it goes in into the if statement, I think at this point it looked like this. Oh, okay, figured it out. Cool. Sorry about that. Okay, and if you're done like figuring out the mutative case, try and write it where you keep this return statement and then change something to make it non-mutative. It's like you return a new linked list, just for like linked list practice. Okay. Hopefully you guys have some idea. What do you guys think what do you think the errors are here? Maybe the first thing when approaching these problems is thinking of the smallest, kind of like a base case kind of thing. So what if I gave it an empty linked list and I wanted to insert a value at the 0th element? Then I should be able to do that, right? If I had link.empty, so if I did insert link.empty 0 and 3, then I should have, then it should change it to be the linked list of just the value 3. If link.rest is link.empty, but then you'd still have, so that's a good thought. But then if I still have if I just input link.empty, then link.empty doesn't have a link.rest. Yeah. So you're on the right track though, Rebecca. The what you'd have to do is you'd have to check if I is 0 and if link is link.empty, then you'd have to let's see, if link.rest is, actually that might work. Yeah. Okay, so there's some like, I was thinking of some, it would be harder if I don't, let's just assume that the linked list always has some elements in it, just to make it easier. Because it's a little harder without it. So then in that case, then Rebecca's answer would work. If that makes sense. So for the most part, I think that's a better question. So if we check if link.rest and link.empty, then we can index error, but we also have to check something about I, right? Where like if I is greater than 0, if I is greater than, 0, So it's actually if I is greater than 1, because we can still add something to the end if it's 1. So does that make sense when we raise an index error? If the next link is empty and the index is going to go over that link.empty spot, then when you raise an index error. And then that raises the next question of if the next element is empty, but then you want to add an element there. So like if I is equal to 1 and link.rest is link.empty, then you'd have to mutatively change things too. So then you have this elif statement where if I is 1 and link.rest is link.empty, then you do some stuff here. Yeah, so you'd have this. And then this part is fine. So this is like another mutative thing. I won't go over it because I'm sure like linked list review might go over it. So, but I wouldn't worry about the point of the debugging thing is catching the bugs, not the syntax as much. So I don't want to worry about that. And then the last part is this line here. So what's wrong with this line if we're mutatively changing this link? Does anybody know? I guess when you're creating a mutative function, what should it return? It should return itself. Like return, yeah, it shouldn't return a new link. Exactly. So this is returning a new link. It shouldn't return a new link. It should return none. And we want to do a recursive call, and that in our function insert is mutative, which means that we can assume that it returns none. So we should really be returning a call to insert. And if we're not inserting anything at this current link, then we can do link.rest I-1 and val. So this is what it would look like. It would just be you don't have this link operator because this is not mutative. And then like cool practice would be to write the function where it isn't mutative, you return a new link, and that would just be by editing this elif statement. Okay, are there any questions here? So this one was a bit harder. But I think that if there's a lot of code writing, like this is a lot of code writing here, you can expect that you don't have to like write out the code. We would test your code writing skills on other problems. It would be more like point out the bug, tell us what's wrong with it. So then in this case, you tell us like, oh, it doesn't add to the end of a linked list correctly, or if you have linked is linked.empty, then like it does this wrong and stuff like that. So, and then you would say this is returning a new linked list, which is wrong. It should be returning just the recursive call. Okay, if there are no questions, then you can go on to, what's this? That's the same thing. Okay, last one that I have is a tree question. So this is, you can assume that we have the class tree imported, or it's like at the top of your function. And then say that there's the height function or the height method for the tree. So like if it's a leaf, then you return 0. Otherwise, you grab the heights for all the branches, and then you return 1 plus the max of the height. So it returns the height of the tree, the maximum number of nodes from the root node to a leaf. So yeah. And so now say we create this B tree class. It's a binary tree, which means that it can only have 0, 1, every node can only have 0, 1, or 2 children. And yeah, and so you're given an init, and you're gonna set 2 branches, self.left and self.right. And if there's more than 2 branches, then you raise an assertion error. And then you have this isLeaf method, which checks if it's a leaf, which is kind of the same as the trees isLeaf method, where if it doesn't have any branches, then it will return true. And then the last one is we have these 2 heights, height 1 and height 2. There are problems with both of them. So try and figure out the problems with those. And then, yes, and there might be a problem with the init. Who knows? This isLeaf is correct. So work on this for a couple minutes. Maybe if you have time, work on the init, but don't worry about it. The biggest thing is figuring out the problem for the heights. And I'm gonna get my charger because it's about to die. I'll be right back. Okay, we have 5 minutes left, so let's go over this one. So the first thing is for the init, it checks if there's more than 2 branches, then you raise an assertion error. If there aren't any branches, then you set them both to none. And then what we're not checking is if there's 1 branch. So if there's 2 branches, then we do self.left, self.right is equal to branches. And then it says self.left to the first element and then self.right to the second one. But if the length of the branches is 1, then we need to set one of them to the value in branches and then one of them to none. Not branches so an empty list is falsy. So if branches is an empty list, then it'll return true and then go into the elif. So it's the same as saying if len of branches is 0. Good question. So then you would do self.left, self.right is equal to branches at 0 and none. So there wasn't a doc test for it, but yeah, just a minor thing in the init. Okay, so what's wrong with height 1? Let's bring up this. So super dot height of self. What's the first thing that's wrong with this?
Wait, also for the self.left, self.right equals branches, what, like, do you need a assignment statement for the self.right or?
No. So where am I? Okay. I don't have, oh yes, here. Would I like to update? Okay, sure. How long is that gonna take? Okay. All right, let's do Python 3. So we can do x, y is equal to 3, 4, and then it can be like that. So that's something cool. Does that make sense,
I
Becca?
could see what you just typed.
Oh, you couldn't? What? Oh, you can only show this. Oh, that's awkward. Okay. So what it showed was x, y is 3, 4. If that's in the interpreter, then if you did x, it would be 3, and then y would be 4.
Oh, so branches is like already a list, so it just like assigns the left one to the first one and then the right one to the second item.
Yeah.
Okay, cool.
Just like a regular tree class, branches is a list
Okay.
of binary trees, or it should be of trees. Yeah.
Okay, thank you.
Okay. So what's wrong with this one? The first one is that super, so B tree doesn't inherit from anything. So super is just going to inherit from, or it's just going to be the object class, which doesn't have a height. So that's what's wrong with it. The second thing is if we changed B tree to inherit from tree, then using this height thing would be wrong because you would iterate through branches of T. But there isn't a self.branches in here. So if you recall that, or you do T.branches. T.branches. So T.branches is an instance attribute, and this only has self.left and self.right. It doesn't have a branches attribute. So that's what's wrong with height 1. Did anyone figure out what's wrong with height 2? So
Change height 1 then, or do we just like say that it's wrong?
Yeah, you can just, I mean, this isn't like an exam, so I'm just saying like this is wrong. On an exam, we'd be clear. It's like, tell us what's wrong with height 1 and height 2, I guess. So that's what's wrong with height 1. A couple problems with that. What's wrong with height 2? So this one is similar to the height function in tree, but slightly different. So if it's a leaf, return 0. Otherwise, we create this list of heights. And if it has a left branch, then we append self.left. If it has a right branch, then we append self.right, and then we return the max of heights. What's wrong with this? You can kind of compare it to this height thing. It gives the value of the branch. Oh, like when you append it, Rebecca? Is that what you mean? Yeah. Oh, so you're on the right track. Yeah. So it doesn't quite give the value. It would have to be like dot entry, which is another thing that's wrong with the init. It doesn't set the entry. But yeah, you're right. So it's appending the tree itself. It's not actually appending the height of the tree. So you'd have to do the recursive call height 2. Height 2. That. And then, and so you can kind of look at this height method here. You have this base case, you have this base case, right? You have this heights thing. So heights is a list, so that's good. Then you go to each branch, that's the for loop. So that's self.left, self.right. And then you call height on B. And then so and then you add it to the list. Originally we had self.left, we weren't calling height on it. And then, so now we fix it by calling height on it, and then we return 1 plus max heights, which is what we have here. So yeah, that's how you fix that one. Any questions? Okay, I'll be on for a little bit longer. If anyone has any questions about anything for the class, because I got nothing right now, or like if you have questions about the exam or something, yeah. But otherwise, I think if you understood the city one, if you understood in nested, the insert one was more of a play on linked lists. But if you understood this one, that's good. But then if you understood B trees, like questions 1, 2, and 4, then I think you'd be pretty good for the exam. Yeah. Okay, cool. You guys are all free to go too. Mm-hmm.
Wait, are you guys gonna upload the recording for this also?
Yes.
Okay, cool.